Hello, everybody. Welcome to Geography 201, Lab 1. This week's lab is on mineralogy and petrology. And so first, before we get into some of the information about the lab, let's cover a little bit of the logistics of our general lab. So the syllabus quiz was due last Sunday at 11:59 p.m. Hopefully everybody did it, but after this video is posted, if you didn't do it, I'm going to be reaching out to you to just make sure there weren't any technological issues and that you know where to find everything on Blackboard. Second, my Zoom office hours are going to be at the same times, on the same days, and with the same links as last week. That should be consistent going forward. If it's not, I'll let you know. And then the last major point that I'm probably going to repeat a few times during this sort of little lecture is the first graded quiz for the lab section is going to be due this coming Sunday at 11:59 p.m. So make sure to get that in. All right. So what we're first going to start with is a very brief PowerPoint covering some of the basics that might not necessarily be covered in the lab itself. And so what we're going to focus on very quickly are the physical properties of minerals. I think you all probably went over this in class, but we're going to very briefly run through it again, just in case you did. So first, color. It's a pretty obvious physical property. Not much you have to do to test it. But what it may be sort of surprising in relation to a streak. So streak is the color of a mineral when it's powdered. But the color of a streak is not always the same as the actual color of the mineral. So you can see that over here in this sort of blurry image where this crystal, this mineral may have a sort of maybe black or dark gray color, but it has an orange streak. And that is true for some minerals and is important in identifying minerals by their physical properties. And luster is the manner in which a mineral shines or reflects lights. So that's usually metallic or non-metallic. So for more physical properties of minerals, crystal form is a big one, but often one that isn't super usable. It represents the geometric shape of the mineral, but the vast majority of minerals in nature have no discernible form. And that's going to be important to remember as you do your lab today. So here you can see some examples of crystal forms with various minerals. If you want to look into what those sorts of different crystal forms are, you can see that in the actual lab text. But here you see this is an example of one with no discernible form. And then cleavage is the breakage of a mineral along planes of weakness in crystal structure. And so here you can see an example of cleavage in the different number of directions, which is how we're going to be considering cleavage for this lab. So here's an example of cleavage in one direction, two directions, and three directions. And generally, that's how we're going to be considering cleavage. So fracture is similar to cleavage, but different. So while cleavage is breakage along planes of weakness in crystal structure, fracture is how it breaks not along planes of weakness in crystal structure. For our purposes, we're concerned about fracture as either conchoidal, or irregular. And on the left here, you see an example of conchoidal fracture, and on the right, you see irregular fracture. So to quickly run through some of the less visual physical properties of minerals, hardness is the resistance of a mineral to scratching or abrasion. We use the Mohs hardness scale for this. Specific gravity is the ratio of mass of a mineral to the mass of an equal volume of water. Magnetism is asking, is a mineral attracted to a magnet? Can it be picked up by a magnet? Those sorts of questions. And tastes, some minerals taste salty, but I wouldn't recommend walking around licking random minerals to try and figure out what they are, and especially not right now. And then finally, calcium carbonate reacts with hydrochloric acid to produce carbon dioxide. And so for minerals that are made up of calcium carbonate, this can be an important identifying characteristic. And here you can see that very quickly in a video. If you have interest in seeing this video again, it is in the actual lab text, which we're now going to switch over to. So when you go on Blackboard and actually click on the file for this lab, this is what you'll see. You should read through the sort of introductory text, which will go into a lot more depth and detail than what I very briefly went over in the PowerPoint. So here you can see it goes through the physical properties of minerals again. And then it goes through a bit of petrology, talking about types of rocks, and a little more detail on that. That should have already been covered in class, and also will be covered to the extent it's important for this lab in a video activity later. So there's two parts to today's lab activities. Lab activity 1, which is a virtual mineral identification. Normally we would do this in person and actually get out minerals and go through some of these physical properties in person, but that's not really possible right now. So instead, we've got this program for virtual mineral identification. And then I'll talk about lab activity 2 a little bit later on. So let's go ahead and click this to see what this website looks like. So here you can see it sort of goes through the definitions and testing methods for the various mineral physical properties. In case you forget anything and don't want to go back and look at the lab text or back and watch this video, this can be a good resource. And then there's the actual mineral identification part of the lab, which the lab provides you a bunch of different minerals and what physical properties can be used to identify them in this context. And this you're probably going to want to keep open for the lab portion of the lab here. So what you're going to do, there are 20 samples down here to identify. I'm going to walk through sample 1 with you guys now, and then you guys are going to do samples 2 through 10 on your own. So let's look at sample 1. What you're going to be doing, there are a number of tests you can run using this program by clicking on them. There are some tests that you'll just do by looking at the image, and then ultimately you're going to want to come up with a mineral name to figure out what this is an image of. So let's run through it. The color is clearly white. Then if we look for streak, the streak is also white. If we test for cleavage and fracture, it's cleaved in one direction and has a regular fracture. So you click those. If we want to look at crystal form, again, unless there's a really obvious crystal form, it's probably not present. In this case, it's not present. For the hardness test, we're going to click through. So sample on hardness 1, sample's not scratched. Hardness 2, not scratched. But at 3, the sample is scratched. And so what that means is that it has a hardness of 2. So your hardness is going to represent for this lab the highest number that does not scratch the mineral. For luster, it's non-metallic. And then we're going to run through these sort of other properties. So non-magnetic, did not react to hydrochloric acid, and has no discernible taste. So with that filled out, now we need to identify the mineral. So we go back to this chart and look through, if we're looking through this chart, we see there are a number of different physical properties that identify minerals, but usually there's only 1 to 2, maybe 3 physical properties that identify one specific mineral. In our case, when we look through this, the only thing that matches the physical properties we saw is gypsum. So it has a hardness of 2, and it can be scratched with a fingernail. So we click gypsum because that's our guess, and congrats, we got it right. Now, probably in the process of doing 2 through 10, you're going to get one wrong. That doesn't matter at all for this lab. So let's say we said it was green and we thought it was olivine. So the lab is going to tell us we missed the color and we missed the mineral name. So we're going to go back, we're going to correct those, and then it'll tell us that we got it right. This activity here is so that you all get a handle and a feel for what mineral identification is like, and how to use mineral physical properties for identification purposes. There are going to be mineral identification questions on the quiz, and so what's going to be provided for you are sorts of these answers here and this mineral identification table. And so with that information, you're going to need to be able to identify minerals. So make sure you get a feel for especially the visual parts of physical properties of minerals so that you are ready for those on the quiz. All right, and so you're going to do, again, samples 2 through 10. Now, for the other part of this lab, so you'll read through again, you'll do activity 1, and you can also find these tables in the actual lab activity in case you need them. And then lab activity 2 is here. And this is going to be a video that is about 29 minutes. You can see the start of that here. And so this is on sedimentary rocks. And so all you're going to do for activity 2 of this lab is watch this video, and down at the bottom of the lab, there is a question sheet about the video. So there's 13 questions that as you're watching the video, you're going to want to write down the answers to these questions. You're not turning this in at all. Again, your only grade for this week is the quiz, but some of the questions here might show up on your quiz. And so it might be useful to make sure that you know the answers to these ones. So for your grade this week, like I said, there's going to be a Blackboard quiz posted at the same time as this video. When you finish the lab, you'll want to go take that quiz. It's due this coming Sunday at 11:59 p.m. So make sure to get it done before then. Again, this is a graded quiz, unlike the syllabus quiz from last week. Important things for this quiz, of course, anything in the lab or in the activities could be tested on, but the big things you're going to want to focus on are making sure you can do that mineral identification, making sure you know the answers to those important questions that cover sort of the key topics of the video that I showed, and finally, making sure that you have a general idea of the physical properties of minerals that I talked through in the presentation earlier in this video. Those are sort of the key points you're going to want to know. The quiz is open notes, so make sure that any notes that you want to use you have ready, but it's important to know that there'll be a time limit on the quiz, and so being familiar with the information, being familiar with the processes and everything will make that quiz easier to complete in the time limit. So make sure you're familiar with everything. If you have any questions, of course, please email me. Please drop in on my Zoom office hours. If you need to be walked through the lab at all, or if you have any questions how the lab works, what something means, I'm here for you guys. And in terms of that, if you don't drop by my office hours or don't email me, I'll talk to you guys next week. Thanks, everybody.